Hi guys, so this time we're gonna do OSPF non-broadcast network, which is going to be our lab number 3. So without further discussing, let's start the nodes and let's see what initial configuration is already in place, right? And then we will continue on enabling OSPF and see how OSPF is going to behave in a non-broadcast network. So this is our router 1. Let me open the console. Here we go. This is 2, this is 3, and this is 4. So let's verify. First thing first, let's verify what we are running here. So let's do show IP interface brief exclude assigned on all of the devices, and we can see that we have Ethernet 0x0 configured, we have loopback 0 configured, and we have tunnel configured. And this tunnel is DMVPN, which is mentioned here. So let's see, router 2 is also configured. Let's see, router 3 is also configured, and router 4 is also configured. So now let's verify that the connectivity over the tunnel is available. So if I ping 10.1.1.2, I have reachability to router 2, to router 3, and to router 4. So I have the reachability as is. So now what we are going to do in this scenario is that we are going to run OSPF on all the devices, right? So let's do that. Let's run OSPF on all the devices. So let's start config T router OSPF 1, and then we have network. But the two networks we are going to involve is the tunnel network, which is going to be in area 0, and the loopback, which is also going to be in area 0. So this is our router 1. So let's do, and before we do that, let's also set the router ID, right? Router ID should be like this. Let's go to 2. Let's do router OSPF 1, and let's do the router ID first. So router ID is 0002, network 10.1.1.2 in area 0, and then all 2s. So this is good. Let's go to router 3, config T router OSPF 1, router ID is 0003, and then the two networks, which is 3.3.3.3 and 10.1.1.3. Then move to router 4. Let's do the same. Router OSPF 1, router ID is 0004, and network is 4, area 0, and the next network is 10.1.1.4 in area 0. So this is what we have done. So now we know that this is a non-broadcast network because it's a DMVPN over the GRE tunnel. What we are going to see is that we do not have any neighbor relationship. If I look at the interfaces, which I can see that I have two interfaces, loopback 0 interface and the tunnel interface inside that, right? So this is the thing which we saw. And if I look at the tunnel 1, let's say we did tunnel 1. So if you look at this one, we see that this is point to point, right? And you can see that right now what is the hello, dad, and wait transmission. We see that neighbor count is 0, right? So all of those stuff, plus we also see we don't see anything much here. We don't have the DR or BDR in this scenario, and the reason for that is because the tunnel is being configured or is being guessed by OSPF as point to point, and this is not the point to point connection, right? So what we need to do in order for them to have a neighbor relationship, we have to change this from point to point to non-broadcast, because we, as per the lab suggests, we have to have non-broadcast, right? So what we are going to do is that under tunnel 1 of all the routers. We will say IP OSPF network non-broadcast. So this is what we're gonna do. Now if you look at show IP OSPF interface brief, we see that now it's in the waiting mode, right? So we'll wait and see what's going on here for 40 seconds. We will wait. Now remember, non-broadcast means that there will be no broadcast or multicast traffic going over the tunnel. So it means that there will be no neighbor coming up. So it means that we have to have some kind of static neighbor relationship, right? So we're still waiting. If I look at the detailed version of this, IP OSPF interface tunnel 1, you will see that right now there's no designated router, there's no backup designated router, and wait time selection is still, you can see we have some time. So now it's 102. So we are gonna wait. It's 59 seconds. You see, it was 120 because we changed to non-broadcast. This changed hello, dead, and wait. This is not 40 as in point to point. If you look at point to point, it was 40, but in broadcast, non-broadcast is 120. So you see, it's 120. Sorry, in non-broadcast is 120. So we'll wait. We'll wait 35 seconds more. And because we don't have that, so after this we need to make sure that we have a neighbor statement in place. Now we will be doing neighbor statement only in on router 1. The reason why we are so if you are willing to have something have a neighbor relationship in this scenario, because router 1 is going to be the hub, the best way is to have this one, only the neighbor statement on router 1. So you can see that right now this has become the designated router. You can see this has become a designated router, and this might be true for all of them, right? So if I look at show IP OSPF interface channel 1, this is a designated router. You see this show IP OSPF interface channel 1, this is the designated router. So everybody is thinking, because there's no one else, so I'm going to be the designated router, right? So everybody is a designated router. So what we are going to do is that we are going to say router OSPF 1, and then we're going to put the neighbor statement that 10.1.1.2 is our neighbor, then 3 is our neighbor, and 4 is our neighbor. So this is what we have done on only on router 1. Once we have done that, you will see that we have the neighbor relationship coming up, right? Now if I look at the neighbors, you will see that router 4 has become DR and the others are DR other, right? So what we are going to see, if I look at show IP route OSPF, you will see that only router number 4 is giving me his address, right? Router number 2 and 3 are not giving me their addresses. Okay? The reason is they might be thinking router 4 as a DR. So if I do neighbor, they are only with me and they think that I am a DR. I'm a BDR, and so they become a DR, right? And if I look at here, they become I'm BDR for them. So router 1 is BDR for them, and for router 4, router 1 is also a BDR, right? Also the BDR. So router 4 is sending me his routes, and that's it. No one else is sending me the route because they don't see me as their DR, right? So they are only going to send it to the DR, and because they are the DR, so they are not sending it to me. They are thinking of sending it to one person only. So if I look at router 2 is, if I look at the command, you can see that router 2 is a designated router, right? And the backup designated router is 001, right? So what's happening? So the neighbor command, what neighbor command did is it makes non-broadcast network type. It enables kind of a multicast so that hello packets can go here and there. The second thing in the non-broadcast, we notice that it's the interval, it is 30 seconds and 120 seconds. The third thing we notice that it requires DR and BDR election. The fourth thing we notice that the next hop IP is not going to change. So if you look at router 1, you see that, right? So if I do show IP route OSPF on all of the routers, so on router 2 we have nothing, on router 3 we have nothing, and on router 4 we have only one, right? And by the way, just to let you know guys, that I did the command on all of them. So non-broadcast is everybody, right? So just to make sure. Now that we have this, if I go back and look at the priority, right? Because this is the most important thing, to look at the priority. So include priority. So if you look at this, every router has a priority of 1. So if you look at the priority of 1, if you look at priority of 1, if you look at priority of 1, the thing which we want is that we want router 2, 3, 4 to have no priorities, because I don't want them to be a DR or BDR. I just want router 1 to be a DR or BDR, right? So what I will be doing is that I will be saying IP OSPF priority 0, and then I will be doing IP OSPF priority 0, and then on router 4 I will be doing the same. Interface tunnel 1 IP OSPF priority 0. So what's gonna happen is that router 1 will become, the DR for everyone. Let's see, router 4 is still playing with me. IP OSPF priority 0. So yeah, this one is done. Maybe we have to let's reset the process on all of them, just for making sure. Clear IP OSPF process. Yes. So you see, everybody goes down, everybody comes back. So let's do show IP OSPF neighbor. So now you can see they are in attempt mode. Again, same priority will go, like wait time, which is 120 seconds. So if I look at show IP OSPF interface now 1, so you can see the wait time is 120. So it will take time. So 120 seconds is 2 minutes, right? So it's 2 minutes. So we have to wait for that, and it doesn't happen here. So, but it happened on router 1, so this will be enough. Yeah, that is fine. So it's not picking up as a DR, router 1 as a DR. So let's verify the neighbor. So 2 is there already, you can see, because 2 isn't been. So if I have done only on router 1, it would have been enough, but I did on all except the 2. But that's fine. We'll wait. So once this has been done, everybody is going to send their packet to router 1, and router 1 is going to send it to everyone else, and that will resolve our issue. All right, so let's see. It's still waiting. So right now I should have the route. I don't have the route from router 2 yet. Am I advertising router 2 correctly? Show run section router OSPF on loopback, show run interface loopback 0. Yeah, it is there. So it should come. Right now I have no OSPF routes, and my neighbors are also waiting. It shouldn't be two-way because it's stuck at two-way, right? So it shouldn't be two-way. So I'll wait. So now it's full. So that is good. Let's see. Now I'm getting it. That's perfect. So wait. Let's see the other ones as well. It's still on attempt. So you can see once it becomes full, I can see it. So now they are full. So I should receive the routes from them. So now I have 2, 3, and 4, right? So I have full reachability now. Now on router 2, if I look at OSPF, I have 1 and 3, not 4. 4 should be here too. Yeah, 4 is there too, 1, 3 and 4. And if I look at here, show IP route OSPF, I have 1, 2 and 4, and on 4 I should have 1, 2 and 3, right? So we have that. So from one perspective I can reach everybody. So if I ping 2.2.2 is the source of loopback 0 or 333, this is a very important point to understand that what's going on. So I can reach all the spoke sites, right? I can reach all the spoke sites. But if I go to the router 2 and I say ping 33333 with the source of loopback 0, that's not going to work, right? And this is not because of the OSPF, right? This is because we have underlay setup is different. So for example, if I go on router 1 and if I look at the tunnel configuration, you will see that I have the static mapping for 3 spokes, right? But if I go on router 2 and I look at show IP show run interface tunnel 1, you see that I only have mapping for router 1. So if I want that to work, I need to make sure that I have the mapping for other routers. Otherwise it's not gonna work, right? So what I need to do, and I can say that okay, do this, but only do this to router 1, right? Because I don't know other routers. So what I can do is that on other devices, so here I can say IP NHRP map 10.1.1.3, but I will point it to router 1. Then 4 I will do the same. That pointed to router 1. I can do the same. So what I can do is that, no, I won't be able to copy. So let's do and go to router 3. Let's do this, and then do IP NHRP map 10.1.1.2 to router 1 and 4. So this way, what I'm doing is that I underlay. I'm setting up the path. How to read that network? Because remember, this is not changing. This is not changing, right? So this is what we have to make sure that we have reachability to, right? So if I go and do IP NHRP map to 10.1.1.2 to 192.1.1.1 and 3, so that it will go by hub. So now if I'm on router 4 and I say ping 2.2.2 with the source of loopback 0, it's reachable. If I do 333, it's reachable, right? So we have to make sure that we have a proper mapping. So now if I look at show IP NHRP map, NHRP, you can see that now I have 3 tunnels, and each tunnel NBM address is router 1, so router 1. So even if I trace, let's say if I trace 10.1.1.2 with a source of loopback 0, it's going to 1. So it's always go to 1, but at least now I know how to reach it, right? And if you want to have a direct relationship, then what you can do is that you can instead of a static mapping, you can have phase 2 or phase 3 running, right? So the phase 2 first packet will go to router 1, and then or phase 3 the same kind of thing with the shortcut command, right? So this is what the lab is all about. So what main points to remember is that it requires DRBDR. We have to make sure that we select the DR by ourselves, right? We know that there is no broadcast or multicast capability, so there should be a unicast. So we must have a neighbor command, and we also know that next hop IP is not going to change, right? So if router 2 is advertising, the neighbors will receive router 2 as the next hop, and the hello interval change. So if you have these concepts regarding non-broadcast in your mind, then you are good to go. We can close this lab here, and I'm going to see you guys in lab number 4. Thank you. Have a good day.